This is a spreadsheet that I've created in LibreOffice. Last video I said, I might have said OpenOffice, but it's LibreOffice. Comes with Ubuntu. Anyway, I've got here a number. It's 2 to the power of 1/12. This makes it so that, well, this is in the coefficient. This is a number that comes up when you go 2 to the power of 1/12. So I've got it right here. And if I go up, that's what the formula looks like. You start with the equal sign. You go 2 with that caret. That's the shift. You put the shift key in the 6. You get that caret symbol, which is the power 2 to the power of. Then I hold the fraction 1/12 in parentheses. And that's a number where that number 1.059 is what results, is resulting from this formula. This is the cell that the formula is in, and this number is like a number that you multiply by to get the fret size increases on a guitar. And it's also what would generate an even tempered scale. That would be how you would get the frequencies or fret sizes for the scales on a piano, guitar, whatever. That's like a kind of a constant multiplication number. So here I've got the spreadsheet, uses this number here, starts with 1, and if I click on this I can show you the symbol, the formula that goes in the spreadsheet. See, that's the cell E4. This is actually cell E5, but it goes to the 1. It takes the 1 in the cell above it, or the number in the cell above it, and multiplies it by 1.059. So here's the formula. E4, which is the cell above that one, the one that this formula is in, and $C and $3 means take the number in cell C3, and just for every formula, this formula is repeated down this column here. So I copied this formula and it automatically adjusts for the cell numbers. So it always takes the cell above it and multiplies it by 1.059. So, the cell below this one, this cell here, 1.2246 is actually 1.059 whatever times 1.059. It ends up with that one. Then this one here is a multiplication of this number times this number up here, and so on and so on. This is how it gets, and it takes 12 steps to get to the 2. So basically, in 12 multiplications, it arrives at 2, which is an octave. So that's kind of a thing that I found in a physics post online that I looked up for how fret sizes increase. That's the constant for multiplication. It's 2 to the 1/12th power. So it makes sense that by the time it'd be 2 to the 12/12th. Okay, so anyway, this is where I get my numbers for the Euler line triangles. So just for convenience, I took this, this is like a unit thing for the sizes of the frets. It's not the actual sizes, it's their proportions. So I multiplied times 4, fret values times 4. None of this is the actual fret sizes, it's just the proportions that the frets grow by. But I multiplied that times 4 so that I could get... yeah.
Dan?
Yes.
Are you on the phone?
No, I'm talking. Okay.
I forgot, that's right. We don't like a bright one, right?
Yeah.
Do we have another 25 watt?
No, we don't.
Oh, shit. Yeah, that's too bright. I forgot that's just like an overnighter,
Okay.
Oh, shoot.
Anyway,
Okay.
I've got these numbers here, and this makes it convenient. I've adjusted the size so that I can use a ruler. You know, something convenient with a ruler. And I figured 4 inches would fit, you know, for a triangle. I'm going to use the proportions. You see, these are the notes right here. That's the notes that correspond to these frets. And so I'm taking these numbers. Here I've adjusted the number sizes so that I could take a corresponding, like for C major, I get a C, an E, and a G. That makes a C major chord. This is where I get those dimensions for building my triangles. I'm making a triangle with the notes of a chord, C, E, and G.
What are you talking to?
Okay, so now I'm taking these drawings that I've made. This is frequency ratios. Okay, using 4 inches as a base. So again, go back to 4 inches as a base. And so that'd be like the C note. It's not an actual dimension, it's just a proportional scale. So as you see, C is equivalent to 4. My E is equivalent to 5. It's very close to 5. It's a 5.039, which is pretty close to 5. And the G is pretty close to 6. It says 5.99. This is what they call an even-tempered scale. It's not the actual exact whole number proportions, but it's real close. Okay, so now that's what my whole thinking is on working on these Euler line triangles. So first I'm going to find my C major, start with the C major chord. Okay, so here's my C major. I took the 4, I wrote down as 400. That's the first note in the chord. Second note in the chord is the E, and that's almost 5, which I drew up as 500. And the third side, which would be the G note, which is 6. Okay, now I do the Euler triangle, and I drew the lines for these circles. Actually have lines that I drew really faintly. They're very lightly drawn. So this center dot is actually generated by okay, first I forgot to mention that each side of the triangle is divided in two, and that's the middle of it, the middle of this line. And I've got the middle of this line right here, and I've got the middle of this line right here, a small mark right there. So now I take a line and I draw it from this center mark of the line of the side. I draw a line across to the point right here, which is called the vertex. So I go across, and I do the same from this side over to the point on the opposite side of it, and the same with here. And that ends up with this dot right here. Okay, that's the Euler line, is these 3 dots, and they're generated by, you do 3 lines for each dot. There's 3 lines going from the center to the point. Then I take what they call the, oh, I forget what this is called, but it goes from the center, and you use a square, and you draw a 90-degree line across the triangle from each side. So 90 degree from the center here. You'd have to use a square. Like in drafting, they make squares for these. So anyway, this ends up over here. And then square from this one up, perpendicular to this line up, goes right there to the dot. So all those 3 lines cross right here. So that's the second dot that I've drawn up. Then this dot here is the perpendicular line that, when perpendicular to this, lines up with this point. So that you'd have to take a square and draw a line square perpendicular to this, which is square, 90 degrees. It goes across like that. Then you do the same for here. You line up to the point right here, perpendicular to this line. Draw a line there. So you've got a line this way, and a line perpendicular to the point there, perpendicular to this line, which is like square, right? So anyway, that generates that dot. Now these are always, this is always twice as far from here to here as it is from here to here. That's a rule that Euler found out in the 1700s. Now what I'm doing is I'm looking at these lengths and measuring them with the ruler and making it relate to these lengths to see how they would be proportional to those numbers that I have on the spreadsheet. And they give me notes that would correspond to certain notes. Now these would be very low frequencies. In this case, I'm doing this with frequency ratios instead of string lengths. And the two are opposite from each other. So the other video that I made was from using string lengths. Like I can go with the drawing that I had for that. That's string length ratios relative to notes. So now I'm doing the opposite. Frequency ratios represented as inches. This is C major. That'd be the C note, the E note, and the G note. And it generates a G, two G's, a lower G, and an even lower G, and then a fairly low D. So these are the Euler notes. The chord is C, E, G, and the Euler line comes up with D and G. Now these may not be perfectly, exact numbers, but this is the closest notes to those ratios. So okay, that's the C major chord. Now I've got the C, well let me go with the C minor before I do that. C minor, same way. Got the 4, which is the C note, 400. Which again, those aren't actual numbers, they're just used for proportions. Okay, so anyway, I drew those same types of numbers, lines and stuff like that. So I get a C, E flat, and G, and the Euler line notes end up being a low B flat and a much lower B flat. And this, the small B flat here is actually below the piano scale. It's so low, such a low note in proportion. And the F note right here. Okay, so I ended up with, now again, this is frequency ratios represented in inches. The other video was string lengths. Again, that's inverses from each other. They're like opposite as far as multiplication and division. They're opposites. So the C major chord, C minor chord is C, E flat, G, and it ends up on the B line. The Euler line ends up looking, showing B flat and F. Okay. So again, this is experimentation to see what kind of relationship that could be, and what it could tell us. Maybe it would be indicating something that could tell us something about music and how notes work together. Again, frequency ratios using 4 inches as a base. C diminished. So the C chord, C note I mean, the E flat, and the G flat, that's a C diminished. And I end up with a C and an E. Right here on the Euler line. The Euler line is these 3 dots line up. It's always twice as far from here to here as it is from here to here. That's something Euler in the 1700s discovered. I may be repeating myself, but my whole objective here is to see what I could find if the Euler line pointed me to how maybe certain notes would fit together in a song or something like that. So C diminished generates, or the chord C diminished chord notes are C, E flat, and G flat. And the Euler line on that triangle generates a C and an E on the Euler line. Okay, then I've got frequency ratios represented in random inches for the purpose of proportion. So I've already said some of this, but here I wrote it down a little more extensively. C sus2 chord. C sus2 chord is a C, a D, and a G. Okay, those are the numbers: 400, 4 inches, 4.5 inches, and 6 inches. Those are the notes of the chord, and arranged in a triangle, they generate an Euler line with, and the Euler line in this case is almost in the corner here, the dot. So it's every triangle, it ends up being twice as far between here and here as it is to here and here, and that happens every time. These 3 dots are always in a straight line, and they always are 2-to-1 ratio. If this is 200, then this is 100. Okay, so anyway, here's the C sus2 chord, C, D, G. The Euler line is C and G. And that's what the C sus chord did also for the, when I used it, the string method, the string length way, which is the inverse. I always end up with 2 notes that match the chord on the Euler line. That's kind of an interesting thing again with the C sus2 chord. Okay, I believe I've got 4 different triangles here that I've experimented with. All right, well, hope this makes sense, and hope this helps someone find notes that go together well. And okay, thank you for watching.